In this video, we will be studying about crystallographic directions. So, what is a crystallographic directions? You can see in this figure that we have a cubic structure uh, placed in a x, y, and z Cartesian coordinate system, and you can see these indices being marked as 100 and 110 and 111. With this, the origin, which is 000, with the values of x, y, and z. So basically, a crystallographic direction is a line between 2 points, or you can say that it is a vector which shows us the direction of crystallographic lattice point. So we will be practicing some of the crystallographic directions, how to draw the directions, how to represent the directions in a cubic structure, and how to read these directions if we have a direction given in a unit cell structure. Okay, so there are some steps to determine the three directional indices. Number one is a vector of convenient length is positioned such that it passes through the origin of the coordinate system. Any vector may be translated throughout the crystal lattice without alteration if parallelism is maintained. So, what does it mean to say that there is a starting point, there is an origin, which would have a certain index, a value of x, y, and z, represented in a square bracket, and the parallel directions would be same, which we'll be discussing that there is a family of directions. Since in a cubic structure, we can, if we rotate the cube, the directions, certain directions are would be equal. Okay. So, secondly, the length of the vector projection on each of the three axes is determined. These are measured in terms of the unit cell dimensions A, B, and C. So, whatever these directions would be, they would present the lattice constants or the lattice parameters A, B, and C, which is this: A, B, and C, the height. In a cube, they would be all equal, but in an orthorhombic or in a different crystal lattice structure, these lattice dimensions would be unequal. So third, we have these three numbers that are multiplied or divided by a common factor to reduce them to the smallest integer values. So if these directions are, for example, these directions are 2, 1, and 1. So we would be dividing this 2 by 2, the whole by 2 basically, to get in a simpler form. We'll be taking that 1 upon 1, 1 upon 2, and 1 upon 2. So we'll be taking 2 as common over here, and the other will be dividing it by 2. So we'll be plotting this 1 upon 2 and 1 upon 2 rather than 2 1 1. Okay. So any number which will be plotting would be less than 1. Okay. So next we have that three indices not separated by comma. These are usually, if you write these indices in a ordered pair, so you have to separate them with a comma, but in crystallographic direction indices, we don't separate by comma. We just use these square brackets, and UVW is the value of the x, y, and the z axis respectively. Okay, so let's begin. So here we have a practice index, that is 0, 1, and 0. So if we have to plot this first, we have to define the origin, that this is the origin, so we'll just mark it as origin. Okay, and you can see that the arrow would be starting from this origin, and it has 0 uh, dimensions in the x-axis, 1 in the y-axis, and 0 in the z-axis. So we'll be just dragging it from the origin to the y-axis at this point. So this is basically x has no value 0, y is 1, and z has 0 value as well. So this is our 0 1 0 direction. Next, the practice question, we have 1 0 0. So you can see that there's a this is the index of x, and both the y and z are 0. So we'll be again marking the origin, that is here 0 0 0, and we'll be just drawing a straight line from the origin to the x-axis. So this is basically 1, this is 1 for y, and this is 1 for z. Okay, so we'll be taking this from the origin to the 1 point. Okay, next we have 0 0 1. In this we again this is the value of z, so we'll be dragging our arrow to the z point as the value 1. You can see that in this x is 0 and y is 0 as well. You should draw a straight line and just using this pointer, so it's not very accurate. So now we have 1 1 and 1 point. So again we'll be marking this origin. This is our origin, and from the origin x is 1, so we come from the origin to this point, this x is 1, then we'll be going 1 towards y. So going towards y, you can follow my pointer. So this is 1 towards y from x, and 1 towards z from xy. So this is 1 towards z from xy. So this is our endpoint. So from the origin, this endpoint, this is our 1 1 and 1 point. So in this we have x as 1, y is 1, and z is 1. Okay, next we have a 0 1 1 index. So this is our origin again. We won't be going towards 1 of x, we'll be starting with 1 of y, because x is 0 here. So 1 towards y and 1 towards z. So this is our endpoint. Just draw a straight line. This arrow is not all straight, but you should draw a straight line from this point to the arrow. So this is your 0 1 1 point. Okay, now what we have is we have a 0 2 0 point. So what we'll do is we'll take 2 as common. So here we have 0 1 0. So what we have to plot is the 0 1 0 will take this 2 as common, because we can only plot with the integer of 1. Okay, so from the origin, x is 0, so we won't be going towards this side. Y is 1, and again z is 0, so we'll be just drawing it as an arrow. So basically 0 2 0 would be equal to 0 1 0. Okay, next we have 1, and you can see over here that it is 1 bar, that is -1 and 1 again. So in this we'll be shifting our origin, since the y index is in the negative form, so we'll be taking our origin. This would be our 0, the 1 would be our 0 and will be moving against this direction towards uh, the 0, 0, 0 value. So we'll be shifting the origin towards y because the y value is in the negative form. So we'll be going here -1. This is 0 of y now. This is 1 of z and 1 of x. So this is now 1 of -1 for y. So we'll from this origin we'll be going -1 towards y, then 1 towards x, and then 1 towards z. So this would be our final point. So this is our direction for 1 bar 1. Okay, we'll be practicing more with these negative indices. In this we have -2, 1 and 2. So what we'll be doing, first of all, we'll be taking 2 as common. So we'll be getting 1 bar over here, 1 upon 2 in the y index and 1 in the z axis. So here you can see that we have a bar at the x index, so we'll be shifting our origin to towards x. So this would be our origin, and we'll be moving into the negative form of y. So 0 for x, 1 for z, and 1 for y. So we'll be going in the invert direction in the x direction. So this would be our -1 in the x, then we'll be going half towards y. As you can see that the y index is half, so we'll be here somewhere in the middle. So again, -1 in the x direction, half in the y direction, and then 1 in the z direction. So this would be our final point. So we'll be matching this. So this would be our direction of 2 bar 1 and 2. Again, this is also equals to this point, this index, that is -1 bar 1 upon 2 and 1. Alright, but while representing this, we'll be writing it as in the simpler integers, that's 2 bar 1 and 2. Okay, so let's do another example. Here we have negative bar 1 bar 1 and 0. Again, we'll be shifting this shifting the origin in the x direction because we have a bar in the x index. So this would be our origin now. Rather than this would be 0 for x, this would be 1 for z and 1 for y. So we'll be moving -1 in the x direction, 1 in the y direction, and 0 in the z direction. So this would be our final point. We'll be matching these two. So this is our 1 bar, 1 and 0 direction. So you should all practice these while drawing a cube. You should practice these directions by your phone. We have another example over here that is 1, 2 bar and 1. Again, we'll be simplifying it as we're taking 2 as common. We'll have 1 upon 2, 1 and 1 upon 2 in the z direction. So there's the bar. So again, we'll be shifting the origin in the y direction because it is a negative index. So this would be 0 for y, 1 for z, and 1 for x. We'll be going -1 in the y direction from this to this, and we'll be going half, which is somewhere this, in the x direction. So -1 for y, half for x, and we have to move 1/2 in the z direction. So this would be around 1/2. So it would be somewhere here. So this would be our time point from here to this. We will draw an arrow. So this is again minus 1 in the y direction, 1/2 in the x direction, and this is half in the z direction as well. So this is our direction for 1, 2 bar and 1. Okay, so there are a lot of examples I have given in the activity. You can also view the book of William D. Gallister and William L. Smith for more help. So I have given this for your practice. You can just print it out and draw it on these cubes, these directions which we solved it in the earlier slides for your own practice. And I have also given the solutions over here. In the blue, you can see that this is the origin I have taken, and in the red, I have marked the directions. Okay. So again, if you are given the these directions, how can you calculate or how can you write down the indices basically? So let's practice this as well. Basically, this is the reverse of what we did in the earlier slides. So you can see that in the first diagram, here is the origin, and in the origin we are not moving in the x direction, but we are only moving in the y direction. We are also not moving in the z direction as well. So this would be 1 for y, 1 for x, and 1 for z. So this is only moving in the y direction, so we'll be writing it as in the square brackets. Sorry, it's not a square bracket. This is a square bracket now. So this is 0 in the x, 1 in the y, and 0 in the z. This is 0 and 0. This would be 1 in the x direction, 0 in the y direction, and 0 in the z direction. So this would be 1, 0, 0. This is 0, 0, 1, as it is only moving in the z direction, not in the x and y direction. In this, you can see that this is the origin. First, it is moving in the y direction, 1. Then it is moving in the x direction, 1, and towards that it is also moving upwards. So this direction would be 1, 1, and 1. Okay. Now in this direction, you can see that it is moving in the x direction, so in the y direction, from here to here, and then it is moving into the top, not in the x direction. So this would be 0, 1, and 1. Then we have this direction, which is again the same as this. This is also 0 and 0. I will repeat it. And this is something new. So in this, x is the origin. The origin is shifted in the x direction, so you can see that this is moving here somewhere. So this should be 1 in the x, because it is moving from this here to here, but in the negative direction. This would be negative. Then in the y, you can see that this is only moved to the half of it. This would be half in y, and in the z is 1 whole. Okay, so we won't be writing half in here, but instead we'll be multiplying it by 2 to get to get the index in the whole number. So it would be 2 bar 1 and 2. So this would be the exact index for this direction. Okay. Then we have this 8th direction, in which there you can see that the origin is shifted in the y direction. So it is moving one in the y and one in the x. So x would be 1, y would be 1 as well, but in the negative part, and z is also moving in the top direction. So it is also 1 in the z. Okay. Next we have, again you can see over here that the origin is shifted in the x direction. So it is moving here and then in the y. So 1 for the x, 1 for the y, and 0 for the z. But the origin in the x is shifted, so it will be negative. It is 0 for x, 1 for z, and 1 for y. Okay, and in this you can see that the y is shifted. So this would be negative 1 for y, and in the x direction you can see it is only moved half. So we will be writing half in the x, and towards the z is also moved to the half of it. So we'll be writing half for z as well. So we'll be multiplying this by 2. So we'll get in the whole numbers. We'll be getting 1, 2 bar, and 1. So this is how we write the indices from a given direction. We have to, first of all, find out where the origin is, which of the axis the origin has shifted to which axis, so that we can get an idea that where is the negative index, and then we can find out the correct direction of correct values for the index. Okay. So next we have a family of directions. So basically, what is the family? It is a set of directions related by a symmetry operations of the lattice. So basically, if you draw this 1 0 0, negative 1 0 0, 0 1 0, then 0 negative 1 0, or 0 0 1, or 0 0 negative 1. So in a cubic, if this dimension is of a cubic structure, so all these directions will be same. For example, if you see that if we have drawn this 0 1 0 and 1 0 0, so if we rotate this cube in this direction, so this would be equal to this, and if we move it upwards, so this would be equivalent to 0 0 1 as well, because in a cube you can change the axis as well. You can take this one is z, and this one is x, and this one is y as well, because all of these are perpendicular and all of these are equal as well. So that is how we can comprise all these directions into a family. So the family is mentioned in these sort of brackets. So basically, we'll be only writing the simplest of the index, that is 100. So we have written it as a family name. Next, if you see that if you plot 110, negative 110, 1 negative 10, negative 1 negative 10, 101, negative 101, 10 negative 1, negative 101, 011, 0 negative 11, 01 negative 1, 0 negative 11. So all these would also have a similar direction. So again, these are these are comprised into this family of 100, 110. Sorry. So in this, I'll give you an example that is there an example here? Yeah, this one is there. So you can see that if you shift this plane backwards, you will get this direction. Okay, so these two directions are equivalent in this. Okay, and lastly, you can see that there is a family of 111 directions in which certain directions are also in the negative index, the negative values of x, y, and z. So again, you can see over here that this 1 negative 1 is equal to this 111. If you rotate this cube in the other direction, you will be getting this. So both of these would be equivalent. So this is how we determine a family of directions. Next we have the angle between directions. So if you want to find out an angle between two crystallographic directions, so what you do is a formula that is cos rho. You can take it theta, you can take it phi, whatever you like. So this is the angle basically. So what we'll be doing is we'll be taking cos inverse of all this, in which we have u1, u2, and u1, v1, and w1, which is one of these directions. Which, for example, we can take this as u1, v1, and w1, and we can take this as u2, v2, and w2. So what we'll be doing, we'll be multiplying it. First u1 into u2 plus v1 into v2 plus w1 into w2. Will be multiplying all the x indices, y indices, and z indices, and then we'll be taking the squares of each, and we'll be taking the square root of all of this, the combined product of the squares, the sum of squares, and then we'll be dividing this and taking cos inverse to find out the angle between these two directions. Okay, so this is very easy. This is just mathematical. You can easily find the angle between two directions, two indices. So here we have an activity in which what you have to do is you have to draw a simple cube, and then you have to sketch these directions for your practice. So in these, which you have to see, what we'll be doing, what you have to do with this two, you just have to take 2 as common. But if you have this G, like in G part, if you have 1, 2, 3, so you'll be taking 3 as common. Okay, so what we'll be getting is 1 over 3, 2 over 3, and 1. So these are all 1 or less, so you can easily plot. So in this case, again, we'll be taking 3 as common, and this will be 1 upon 3, negative 1, and 1. So you just draw a cube. I mentioned the indices 1, 1, 1. If you are shifting the origin, then mark the origin first, and then start sketching these directions. In the activity 2, what you have to do is you have to determine the indices for the direction shown in the following. Cubic unit cell, so you can see that this is the origin now, and the direction is moving towards this side. Again from right here, this is A, this is B, this is B, and this is C from the middle. So try to find out the indices for these directions as well. So this is very easy. I hope you can easily do it at your own. So that is all for this video. Thank you.